Hello and welcome to section 2.5, where we are going to talk about applications of percents and solving problems with percents in them. Percents are a very important part of mathematics, specifically in a branch of mathematics called statistics. Many of you, probably 60% of you, will end up having to take a statistics class sometimes during your college experience. Statistics is a newer branch of mathematics because it requires a lot of calculation that only computers can do. But statistics is super important because it's the math that allows us to try to prove things. For example, if we were to take a bunch of data, statistics is the study of that data. And if you wanted to try to prove that a miracle drug can make you smarter, well, you would put some of those people on the drug and then have a control group and then run the data to see if that drug really did make you smarter. And statistics is one of those things that you would then apply to that. And statistics is all about understanding percents and understanding data. I really like this little comic strip here. It says, I can give you my 93.4% assurance that there is less than a 65.6% possibility that this exercise will simply generate 34.8% more meaningless statistics. Now, statistics is, like I said, is all about percents. As you can see, it's got lots of percents there. And if you don't understand percents, well, that can be something that's quite meaningless. And so we do want to talk about percents and get you ready. For those of you that are going to take a statistics class, you'll want to pay extra close attention so that you can be successful in this class. So before we get started with the actual math, we need to understand how to translate a percent problem. So I've written up here some of the translation words that you need to be familiar with. The first is of. Anytime you see the word of in a percent problem, that means to multiply. Of means multiplication. Anytime you see is, well, is means an equal. So anytime you see is in a sentence with percents, you're going to put an equal sign. If you ever see what number, well, that means to put a variable. So, for example, you would put the variable x. And percent means 1 over 100. Anytime you have a number with a percent, you're going to want to move the decimal place over 2 places. Let's look at an example. So the first problem here says, what is 13% of 80? What is 13% of 80? The first thing we need to do is translate this problem. So notice they start off with what. Well, what means a variable. So what? So we're going to put x is. Anytime you see an is, we're going to use equals. So what is 13%? Now don't forget, we're going to write 13. But we need to move the decimal place over 2 spots. So we're going to put 0.13 because it's a percent. Of is another translation word. Remember, of means multiply. Sometimes I remember, because of is a circle, sometimes I remember, of means to multiply because it's got a circle in it. Hopefully, maybe that'll help you remember what of means. And then 80, well, we just have 80. So this problem is asking us to do 0.13 times 80, and that'll give us the value. So using our calculator here, we would do 0.13 times 80 and push the enter button, and we find out that x equals 10.4. So 13% of 80 is 10.4. Let's try to translate this next one here. Here we have 45% of what number is 28. So 45%, that's going to translate into 45, but we have to move the decimal place over 2. Of, remember that means our multiplication. What number? I'm going to put an x. Is, that's equals 28. Again, if you know these translation words, then setting up a percentage problem is pretty simple. We're left with 0.45 times x equals 28. So how am I going to undo? I want to get x by itself. How do I undo times by 0.45? So to the opposite law of opposition of 0.45, it is divide by 0.45. So we would divide both sides by 0.45, because that's the opposite of multiplication, and I'd have 28 divided by 0.45. And we get the answer of 62.222222. So I'm going to use a bar over the top of that to represent 2's going on forever. So let's take a look at 3 more here. Just make sure that we can do these. It says 32, so I'd write 32, is, what does is mean? Is means equals what percent? So I'm going to put x, because what, and percent, that's the x value, so we don't know exactly yet, of 50. So I'm going to write of 50. So I want to solve for x, so I'm going to go ahead and undo the multiplication by dividing both sides. So I get 32 divided by 50, and I get 0.64. So 0.64 equals x percent. But remember, we're looking for a percent here. So to find x being a percent, we would need to move the decimal place over to the right 2 spots to find out that it's 64%. So again, 32 is what percent of 50? Well, it's 64%. Okay, let's try this next one here. It says that we have 3 is means equals 15%. Now that's got a percent on it, so we need to move the decimal place over to the left 2 spots. Of means multiplication. What number? So I want to undo the multiplication here. I'm going to divide. We'll take 3 divided by 0.15 as we divide both sides of the equation, and I get x equals 20. 3 is 15% of 20. And the last one here says what number is 11% of 49. So what number is means equals 11%. Now percent means we move the decimal place. Of means multiplication. 49. And so to get x, we just have to multiply 0.11 times 49. So I would go 0.11 times 49. And we get 5.39. So again, this is how you translate sentences into equations in which you can solve. Okay, let's put up some problems for you guys. Take out your video notebook and give these a try. Okay, so here are your 3 equations to try out. Please pause the video and work these out. When you're ready to resume and check your answers, press the play button. Okay, so what number is 60% of 70? We need to translate this. What number means a variable. Is means an equal sign. 60% means 0.60. Of means multiply, and we have a 70 here. So in this problem, to find out what x is, all we needed to do is do 0.60 times 70. So you could use your calculator to do that. 0.60. You don't actually need to put the 0 in there, but that's fine. 0.60 times 70 equals 42. That's what you should have got for the first one. On this next one, it says 21. 21 is means equals what percent? That is a number with a percent. We're not sure what the percent is going to be. Of 30 means multiply. Now if I want to solve for x, I'm going to need to get rid of this multiply by 30. So I'm going to divide both sides by 30. And I'm going to get 21 divided by 30. Now that 0.7 equals x as a percent. So we're going to need to move the decimal place over 2 spots to get 70% as our value. So 21 is 70% of 30. On this last one, 30 is means equals 40% means 0.40, and of means multiply. What number is x? So to solve this one, we're going to divide both sides by 0.4. 30 divided by 0.4 is 75. So one of the great applications of percentages, we talked about statistics, and that's when we get more advanced, but some basic application are when we're dealing with tips and taxes. So for example, if you go out to a meal and you spend $24, and you want to leave a 15% tax, a 15% tip, that's about average. That's what you should be doing. That's kind of our culture. We say 15 to 20% tip. We can calculate that by using the same thing. Basically, what we would ask ourselves is 15% of $24 is what tip? And so to calculate that, we would just go 0.15. Remember, multiply is our of. $24 is means equal sign, and what tip? Well, that's just the variable. And so all we would have to do to calculate the tip would be to do 0.15 times $24, and we find out that the tip we should leave is about $3.60. So that's one way to apply percentages, is doing tips. We can also do a tax. Let's say that you go out and buy a new Xbox, and it's $220, or a TV, or I don't know what you're going to buy for $220. But it's not going to just cost you $220. We know that when you go to a store and you go to the register, it's never $220. It's always going to be more than the price because there's a tax. Here in Idaho, the tax is 6%. In some places, it's a lot higher. Like California, you have a 9% tax, almost 10, I think. So to do this tax, we would do $220 times 0.06, because we're asking ourselves 6% of $220 is what? So 220 times 0.06 equals the tax. And so we would just simply do that in our calculator. Do 220 times 0.06 and push the equal button. We're going to find out that the tax is $13.20 that they're going to tack on to the price of this Xbox. Now, that's not... So the total price, if you were asked, sometimes in word problems you'll be asked, what's the tax? If you were asked that, you'd say, oh, the tax is $13.20. But if you were asked for the total price, well, that would be the original plus the tax. The original price plus the tax. In that case, we would take the tax and add the original price, which was $220. And so the register is going to say that we owe $233.20. So do be aware that when you do a word problem, that you make sure you're answering the question that they are actually asking. So again, we talked about statistics being a major role of percentages. We can solve a statistics problem. For example, let's say that we were polling a bunch of people in Rexburg, and we asked them if they were Democrat, Republican, or Independent. In fact, the newspaper just did this recently. So you can see the total from this picture, the total number of registered voters. And what we have here is we can ask ourselves, hey, if there's the total number in this survey were 15,041, and let's just pick out one here. Let's pick out the independents. There were 8,015 independents in Madison County. So what percentage is that? So in other words, 8,015 is what percent? Is what percent of 15,041? We can figure out, using this same idea that we're learning here in this lesson, what percent of voters are independent in Madison County. To do that, we would just write an equation. We would say 8,015 means equals what percent, we don't know, of 15,041. So to solve for x, we would divide both sides by 15,041. So it would be 8,115 divided by 15,041. That gets us 0.532 equals x percent. So the actual percent then, we would move the decimal place to the right 2 spots giving us 53.2%. So we learned that 53.2% of voters in Madison County are independent. Okay, so now it's your turn to pause the video and give these 3 word problem applications a try. It might help to first write them as a sentence, and then an equation, translate it to an equation, and then solve for the variable. Go ahead and pause the video, give these a try, and then push the play button when you are ready to check your answers. Okay, time to take a look at this. Jim bought a car with a sticker price of $4,900. He has to pay a 9% tax. How much is the tax? So, in other words, we are doing 9% of $4,900 equals what? That's the problem that we're doing here. So we need to do 0.09 times 4,900, and that'll help us find out what the tax is of this car. So $4,900 times 0.09, he's going to have to pay $441 for the tax. $441 is going to be the tax for that car. Okay, so let's take a look at number 2. Sally left a $4.32 for a tip. The tip was 15% of the meal. What was the cost of the meal? So here we have 15% of what? The cost of the meal equals $4.32. So 15% of the meal, of the cost of the meal, was $4.32. So as we write this to an equation, it would be 0.15x equals 4.32. To solve this, we are going to take 4.32 and divide it by 0.15 to get $28.80. Okay, nice. And the last one here, it says in a survey of 990 people, 410 said they had been in a car wreck. What percent is this? So we are looking for 410 is what percent of 990? So writing that out, it would be 410. Is means equals. X is what? Of means multiply, 990. And so we would just divide by 990. So we'd have 410 divided by 990. And we get 41.4%. We'll go ahead and round that. 41.4%. Okay, great. Well, that is the lesson on percentages. You may, when you're ready to begin, go ahead and push the start button down at the bottom and work through those problems. If you need help, feel free to contact a tutor, stop by the tutor center, or even contact your teacher. Thanks for watching. The next type of problem that we want to go to are increase and decrease of price problems. So, for example, if Martha bought a new couch, the final price after a 6% tax was $583. What was the initial price of the couch? Now, this is an interesting problem that can't be solved just with simple percents. What we need to do is let X represent the initial price. We want X to represent the initial price, and you're going to do this on all the problems. X was the initial price, and then what happened to X? Well, we added a tax to it, and the way we would write the tax is that it was 0.06 of the original price. So we put 0.06, that represents 6%, and X is the initial or original price, and we know that that equals 583. So again, we're always going to use a variable that will represent the initial price. We then can add these two together, x plus 0.06x. Well, you may want to think of this as being 1x. When you add those together, we get 1.06x equals 583. And our last step is simply to divide by 1.06. When we do 583 divided by 1.06, we do that in our calculator, we find out that the initial price, the original price of this couch, was $550. Okay, so here's another one that's just the exact same idea. Ben just got an amazing 40% off deal on this new bicycle. After the discount, he only ended up paying $240 for the bike. Now that's sweet. But the question is, so what was the original price? If it weren't on sale, if I wanted to go find it today and it's not on sale, how much would I end up paying for the bike? So again, we're always going to allow the variable to represent the initial price. So I'm going to say X was the initial price. Initial price. I don't know what it was. That's what we're trying to figure out. But we know that he got a discount off the initial price. In fact, they cut some money off, meaning that we're going to subtract. And they subtracted 40% off the initial price. So again, we write 40% as a decimal, and we write X there because it was 40% off that price. So this is the discount. We know that at the end he only ended up paying $240. So now with this equation set up, we can solve. Again, this is 1x, so 1x minus 0.4x is 0.6x. That equals 240. We then can divide by 0.6, and 240 divided by 0.6 ends up being $400. So again, when solving a price increase or decrease problem, you're going to want to let the variable represent the initial price. Okay, it's time for you to try a couple problems. Go ahead and pause the video and give these two word problems a try. Remember, when doing price increase and decrease problems, we always let the variable represent the initial amount. Go ahead and pause it and press the play button when you're ready to resume. Okay, let's look at it. Here we go. So this is Susan, and she just found out that her initial investment has gone up 35%. Sweet! That's a good deal. So the question is, what originally did she put into it? So that's what we're going to let X represent, is the initial investment. And we know that it went up, which means we're going to use plus. It went up 35%. That initial investment went up 35%. And now it's worth $3,800. So X plus 0.35X, well, that's 1.35X. And that equals 3,800. We take 3,800 and divide by 1.35 to find out that her initial investment was about $2,814.81. That's what she initially put into it, and now it's gone up that much amount. Okay, great. How'd you do with this Evelyn problem? Evelyn got a 25% off discount, so she only ended up paying $42 for the shoes. The question is, what was the initial price of these shoes? So the initial price would be X. She got a discount, so we subtract that discount of 0.25x, and that equals $42. So 1x minus 0.25x is 0.75x. That equals 42. When we take 42 and divide it by 0.75, we find out that the initial price of those shoes, if she didn't have the discount, she would have ended up paying $56. So that's how you solve price increase and decrease problems. Nice work.